My name is Sarah Sanders, and this is my demonstration project for Dr. Greg Buckner's Mae535 class. I'm going to be talking about magnetorheological fluids versus ferrofluids. In both cases, both fluids are non-Newtonian fluids, meaning that they're non-linear, rather their viscosities are non-linear at a constant temperature. So in this jar I have a homemade solution of iron shavings and motor oil, and as you can see, it's fairly liquid. When I apply a magnetic field to it, which I have this very strong neodymium magnet, which is has about 25 pounds of pull force, I apply the magnetic field to the solution. You can't see much of a change, but if I rotate the jar, you can see that it doesn't behave as much like a fluid. However, if I release the magnetic field, it collapses back into a fluid state. This has practical applications in active suspension systems, which is currently being used by Lord Corporation, as Dr. Buckner has referenced in class. And if I take this plastic knife and I stick it into the jar in the solution, then apply the magnetic field, it could also be used in industry as a robotic gripper to transport parts from one place to another, and specifically parts of irregular shape and size. In this jar I have the ferrofluid, which I purchased from Applied Magnets, and it's made by Ferrotech. And the major difference between the ferrofluids and the Mrfluids is that the ferrofluids have ferromagnetic particles suspended in oil, and those ferromagnetic particles are on the nanoscale, whereas the ferromagnetic particles in the Mrfluid are on the microscale. So about 1,000 times bigger, and you can see that 1,000 times size difference makes a significant difference in applicability. So applying the magnetic field to the ferrofluid creates what's commonly referred to as spiking, which is a pretty powerful aesthetic effect. And if I pull that around and up to the side, you can see that follows. It almost looks a little bit like a sea urchin. Now if I remove the magnetic field, it collapses back into a liquid, similarly to the Mrfluid. Well, one interesting thing about that, it has a very opposite effect of the Mrfluid, whereas if I take a little bit and put it on this other neodymium magnet, which I'm going to take a little bit off of this spoon, putting it on the end of this magnet, put it on some of this parchment paper, it tends to kind of float almost frictionlessly. So you have this whole other application of frictionless bearings, whereas the Mrfluid is very friction full and holds things in place, whereas the ferrofluid allows things captured in a magnetic field to flow effortlessly. And I'll apply a little bit more just for demonstration's sake, as the parchment paper has absorbed a lot of it. This might be too much, it's probably going to fall over, but that's okay. It still glides around very, very effortlessly, and that's a pretty important side effect of this fluid in the magnetic field. So that's it. Thank you for your time.